So this is the panel for the double speed squirrel cage 3-phase induction motor. As you can see that on the top of the panel there are different meters like voltmeter, ammeter. These are the AC meters, and then we have a watt meter. Again, this is a AC watt meter. Along with that we have a power factor meter. We also have a load indicator for the measurement of torque. We will use this load indicator. We also have two DC, a voltmeter here and an ammeter, and we will be using these to measure the load current and load voltage. Then on the left side you can see that there is a miniature circuit breaker, and it is working as a switch as well as a 3-pole protection, current protection. Contactor to turn on, the green is to turn on and red is to turn off the 3-phase supply, and this is the red, yellow and blue for the 3-phase supply. Then we have a DC output of 220 volts. We will not use this one for the motor but for the generator, for the dynamo. Then there is a variable resistor which is the rheostat, the potentiometer which we will be using for varying the or controlling the excitation current of our DC shunt generator. We also have a load here. This is a load which we are going to put on our dynamo, and this is the digital power meter, and we will be preferring this for our readings because the analog system, the watt meter and the power factor meter are not that accurate, so we will be using the digital power meter for power factor as well as the watts. This is the 3-phase induction motor, double speed. Connections are same. We have 6 windings connections which are coming out, 3 for phase and 3 for the star point. Again, you can see that there are multiple windings which are connected together. So as I told you earlier that this is for the pole replacement method, and due to which we get a good speed control of this this 3-phase induction motor. We also have a DC motor over here. This is a DC shunt machine actually, which we'll be using as a dynamo. So let's start the connections. So for the connections, as you can see in your diagram, first of all we are going to make the connections for the 3-phase induction motor. So red, yellow and blue phases, and then the neutral. For the red phase we will connect the power factor meter and the watt meter, the power meter, the digital power meter to measure the power of the system, and we will be connecting our voltmeter between yellow and blue, and we will be also connecting an ammeter with the yellow phase. So let's start the connections. First of all I am going to connect the red phase with the power factor meter and the voltmeter. I also have to check that if the power factor meter is working correctly, because a few choices, like some cases, as I have told you earlier, that the power potential and the current coil, they are like interchange. Okay, so I'm going to show you that how we can easily find the working of potential coil and our current coil. So first of all, just keep it on the continuity and connect these two, turn it on, and the potentiometer, the potential transformer will not show you anything here. So no buzzer, it means that there is a fair amount of resistance. And for the current coil, it must buzz. So you can see that now this is buzzing, so it means that this is the current coil. So the correct configuration is here, so we can work on it. So let's start with the red phase, and let's connect the red phase with our, first of all, with our potential transformer or the potential coil, and this connection will be going to the current coil as well. So I will try to use some small wires here. Okay, so next what we are going to do is that we are going to connect the potential coil with the current coil. So there you go, potential coil with the current coil, and then this will be continued to our power meter. As you know that I am not using that watt meter, so it will be continued to the power meter here. Then similar connections like the ones in the power factor meter, you have to convey the current here, or you can simply connect it here as well. So it's up to you that you are giving the connection to current coil, or you can connect it with the potential coil. So because these will be a combined connection, so I'm just connecting it to current coil and then transferring the connection to the potential coil as well. Similarly, I will also connect this meter for power factor, because leading or lagging will be showed here, and then the exact power factor we will see it here. So again, it's a very huge connection, this one, but I am going to connect it. So here you go. So now this is our power factor meter, and then this connection will be going to the okay, so just a minute, we have to connect it with the out. Okay, so this is here. Now this let me show you. So now we have to connect it to the out. Okay, so like this is the out of the CT. This will connect it to that other meter CT, and then this connection will be done here. So this is how you connect the meters, and then now this connection will be going to your induction motor. So I'm going to find a longer wire where it will be connected. So here you go. So the out of this meter is going to be connected with the red phase here. So this concludes the connection of power meter. I know this is a little bit of a hectic connection, like too many connections, congested one, but this is how it's done. I'm just leaving the neutral points here, because first I have to make a star point here. So let's make a star point on the motor, and once we have created a star point, then we can connect our neutral to that point. So this is the star point, and now, because as you can see in your power supply that there is no neutral. Okay, so there is no neutral here. So what you can do is that you can connect the potential coil with the with your star one. So first of all, you have to connect all of these potential coils in common. So you have to go for a common connection, and once you have established this, you have completed this common connection, then you can connect it to your star point. So this concludes the connection of the power meter and also the star point or the neutral point. Next we have to connect the yellow phase. Again, for the yellow phase, as I told you earlier, that we will be connecting it with ammeter, but as you know that this ammeter is not going to give us a good reading, but still like if we are getting a good amount of current, so we will calculate it here. Otherwise we will go for my digital multimeter. So simple, just connect it here to your AC ammeter, and this ammeter will be now connected in series with your yellow winding of the 3-phase induction motor. So here you go. Next we have to connect the blue phase. So blue phase is very simple. Just connect the supply, the blue phase of your supply, to the blue phase of the machine. Final connection for the induction motor are to connect the blue and yellow phases to your voltmeter. So this one is the blue one, sorry, the yellow. This one is the yellow, and I'm going to connect it to the voltmeter, and then for the blue I'm going to connect the meter again. So now this concludes the connection for the machine. Next we have to connect the generator, and for the generator, as you know that there will be a connection from the DC power supply, and then it will be continued towards the field winding. Okay, so continuing our connection, now this DC power supply I will connect it to the rheostat, and this connection will be continued towards the field supply. So here you go. I have connected to the rheostat, and then now the connection from the rheostat will be continued here to the field winding. Here you go, this is the field winding. I have connected it. Then for the negative, I'll just connect it directly here. So now this is the field excitation. Next we have to connect the load using the meter. So A1, and I'm going to use a multimeter for this. So this is the multimeter. As you can see, I have written IL, and the range is set to DC 20 amperes. So here you go, this is A. And then you will connect it with the common. Here you go, this is the common, and this connection will be continued all the way to your load. So here you go, this is the load. Also I'm going to set this meter here somewhere, so you can see the voltages and the currents as well. I will just adjust it in a moment for the readings, but I hope right now you can have a good overview. You can see it, but I will just adjust it. Just give me some time after completing the connections. Okay, so now I have set this connection here, so the meter is here. I think this shows a good view here, and also this is just above the just below the load, so you'll get a good overview here. And the final connection is that we are going to connect this A2 with our load. So Sarafi will assist me. Okay. So now this concludes the connection, and let's give it a try. And just turn on the load to 1. Okay, so let's give it a try. Let's turn on the okay, so you can see it's a lot of speed here. So sir, can you please increase the load up to 3? Yes. So as you can see that this is now this motor is moving very fast here, and okay, so now the setup is complete. Voltage, motor current, this is the input current. Power factor, we will decide if it's leading or lagging from here, and I'm just going to adjust it to 1, sorry, to 1. So 0 error and 1 point. So it will give us an overview of lagging and leading power factor. This is lag and this is lead. And then power meter, this one will be for power and this one will be for the power factor for digital, because we won't get a good overview here. And then also the load here, and Sarafi will measure the speed using the tachometer. Okay sir, turn on the supply. So the voltage is around 400 volts, the current is around 0.2, and this is the speed. Okay, 2678. Okay, power factor, and this is the power factor is around 0.93. Okay, and this is the load current 0.27. Let's increase the load. Voltage is same, current is been increased, load has been increased, power factor, let's see, the speed is now 2617. This is the power 144, and the power factor is around 0.945. Load current is 0.5. Again the current has increased. Input current, power factor is 0.954, power is 173, speed is now 2516, and speed has decreased. Load current is 0.7. Again we have increased the load. The current is now up to 1 amperes. Power factor is 0.957. Speed is now 2360. Okay. And also the power is 212. So for the final reading, 400 volts, 1.1 amperes. Speed is reduced to 2124. Power factor is now 0.957, and the power is 55. Load current is 0.9. Okay, so this concludes our experiment. I know that this load indicator was showing the reading in minus, but you have to assume it's positive, because there is some error or some error in the load, but it is increasing as the load on the motor is increased. So that's why just assume it, don't take it in negative. So this was the experiment, and let's go towards the conclusion of the experiment.